Data science. All right. Amazing. I am too old to learn new things. I've told people that, right? In any case, we look forward to having an interesting evening of discussion, brainstorming. This Internet of Things boom is new. We are all learning. By no means is this a solved problem. That's why we're excited to have panelists from Cisco, Siemens, Rockwell, and Microsoft. How can I forget? Not me. Somebody a lot smarter than me. Talk to us about where they see the industry going and what are the emerging challenges and opportunities. Right? With that, welcome once again to Microsoft, and we look forward to the next hour or so, hour and a half, of stimulating and exciting discussion. Thank you. With that, Pasha.
Thank you. Thanks, Jamie, for having us tonight. I think there are a lot of new members to the Hive think tank tonight. Can you raise your hand? Actually, I'm sure there are a lot of new members. Great, welcome. So I'm going to do my introduction. A lot of people here in the room already know about the Hive think tank, but I'm happy to give you a little bit more details for the newbies. So my name is Pashu. I'm the Marketing and Partnerships Manager for the Hive. And the Hive think tank is a community of practitioners, data scientists, engineers, designers, artists focused on big data. We host events every week. We have from 200 to 600 attendees. We've had over 150 speakers. We hosted now, I think, over 100 events. And we have 6,000 members, which make up the Hive think tank one of the largest data-driven community in the world. These are our upcoming events. So as I told you, we have almost events every week. There are a few other more coming in November, so make sure to stay tuned. Next week, we have an event with Professor Sandy Pentland. You may have heard about him. He's a renowned data scientist, actually one of the most powerful data scientists according to Forbes magazine. And then we have an exciting panel discussion on Hadoop, and stay tuned for upcoming events in November. We'd like to thank our sponsors tonight, and we'd like to thank Microsoft for hosting us, and we'd like to thank our partners. Prime is here actually. We have a few people from Prime too. Yeah, thank you for coming. And with that, sorry, Ravi, I just have a few slides that I don't know why, yeah, I should have had them before. So, GigaOM is our partner tonight, and they are offering 25% off to the GigaOM Structure Conference. You just have to type in the Hive. So that might be of interest for you because it's related to our topic tonight. And CAFIT, the organizers are here tonight as well, so if you have any questions, you can reach out to them. And so CAFIT is happening on November 19 and November 20th, and it's going to be on energy efficiency and smart factories. So again, it's related to tonight's topic. And we might have a discount, but I'll send you a thank you email with all the details tomorrow morning. And with this, I'll hand the microphone, sorry about that, to Ravi, who is the founder of the Hive. Thank you.
Thank you, Pasha. I'm going to be brief today because we have another sponsor, Foghorn, who's just going to talk about their company. So for those of you who are new, the Hive is an entity that creates or incubates companies, and then we fund them and launch them. Typically, we are investing $1.5 million to $3 million in these companies just to make them sort of viable and on the path to success. Big data is a big space, and so we are focused there primarily on applications and use cases of data. Here are some of the companies of the Hive, and so they range from advertising to retail analytics to security, Foghorn will kind of talk about themselves. For today's conversation, please use the hashtag HiveData so that others can also follow what you're saying. And with that, I'd like to introduce Kamesh to tell us a little bit about Foghorn.
Thanks, Ravi. Yeah, so the buzzword of the day is Internet of Things, and Internet of Things is not just a buzzword, it's a promise that by the turn of this decade, we're going to have 50 billion endpoints connected to the Internet. And like we have seen in the past 5 years, the success of cloud computing, and we as technologists intuitively think of applications running on the cloud, and all of them, all the 50 billion endpoints being connected to the applications in the cloud. But wait, IoT also brings new use cases beyond smartphones, beyond wearables. It brings in use cases that are mission critical. It brings in use cases around manufacturing, energy, critical essential utilities like water and healthcare and so on and so forth. And therefore, is this really the only architecture that we should be looking at? So are there concerns around reliability, scalability, security, performance, latency, and costs, and so on and so forth? Is the cloud really too far away for some of these use cases? And this has been one of the most important kind of thought process amongst many of the infrastructure technology leaders, and thinking whether the cloud can be extended downwards, closer to these things, and enable the resolution of some of the challenges we saw earlier. And this has led to the genesis of a new paradigm in infrastructure called fog computing. And some of these technologists, you must have heard of this. This is the next gen buzzword after IoT. But the fact is that some of these technology leaders come from very large companies like Cisco, Intel, and Qualcomm. And I'm sure you'll learn a lot more about fog computing in this panel itself. And while fog computing brings in this disruptive paradigm of distributed systems and infrastructure, what does it mean to the developer? As it is today, developers have to worry about scaling applications between private cloud, which is part of large enterprises, and public cloud, which has so much buzz and adoption all across. Now they have to worry about this messy mesh of these end devices, which are the fog edge devices, and which might be inserted at strategic points, which might be scalable as infrastructure. But does this really simplify the life of a developer? And this is exactly the problem that Foghorn tries to address. And Foghorn envisions the Internet of Things to evolve into Internet of Applications and enable the developers to develop applications on the PaaS system of their choice and allow the applications to trickle down across this complex mesh of multi-tiered infrastructure and deliver the value that these 50 billion devices are trying to get. And with this, we hope to enable this new generation of applications that can make this buzz of IoT become more real, and all of us consume the promises that IoT makes. So like all startups, we are hiring. We are looking for technologists, product leaders who want to sink their teeth into this new paradigm of distributed systems. We'll be featuring our product live in next week's IoT World Forum in Chicago. And we have a small booth set up outside, and we look forward to speaking to you more. We thank the Hive for giving this opportunity to sponsor this event, and Microsoft for hosting us. Thank you.
So with that, I'd like to introduce Jeff Johnson from Firelake Capital. Jeff was previously a group VP at ABB. For those of you in the industrial segment, ABB is a Swiss industrial controls company. And before that has been in a number of startups and places like Intel and so forth.
I think this should eventually pop on. Maybe. Yeah, there we go. So maybe if the panel could come up as well, rather than my poor attempt to introduce you, I'll let you introduce yourselves, and we can take things from there. So please, maybe Beth, you could start.
Sure. Who would you like?
Who are you?
My name is Beth Parkinson, and I'm with Rockwell Automation.
Hi, my name is Leah Kong. I'm with Cisco Systems.
And what do you do for Cisco?
So I am the CTO for Internet of Everything solution. Because Cisco believes Internet of Things is not good enough. So we need to really connect everything together. So we created a new keyword called IoE.
Perfect. Beth, if you could talk more about it.
Sure. I am the director of our Connected Enterprise Initiative. And what does that mean? Well, we've really been talking about how you connect the shop floor to the top floor and connecting the supply and demand chains for decades, really. But really things are coming to light now with the Internet of Things. It's accelerating that. So I'm responsible for that initiative at Rockwell.
Great.
I'm Mitch Bond with Siemens, and I work in the what's called the HMI, or Human Machine Interface Center of Competence for Siemens, and what we're responsible for are the SCADA applications. And these are the systems that create lots of big data.
So let's stop there. How many people know what SCADA is? Raise your hand.
Excellent. And it stands for Supervisory Control and Data Acquisition. And these are systems that have been done for years. But again, we're responsible for those applications throughout the Americas.
Great, thanks. Reed?
Hi, my name is Rohan Bhargava. I'm the technology strategist responsible for the solutions that we take to our global customers and partners in manufacturing, oil and gas, automotive, high-tech, industrial, and aerospace. And my area of focus is primarily things like connected vehicle, industrial internet, and connected devices, somewhat in the high-tech space that flow into the consumer space as well.
Great. So before we get started, I thought I would just try to get a better sense of the audience for those of us sitting up here. In terms of background, how many folks back here have computer science, computer engineering? Wow, that's a lot. Mechanical engineering, anyone? All right. Silicon Valley has not forgotten you, I promise.
We need you.
There you go. Electrical engineering? They haven't forgotten you either. And then other? All right. Perfect. I was also curious before we get started. I mean, I'm assuming everybody here has heard of Microsoft and Cisco. Let me say it this way. If you haven't heard of Microsoft or Cisco, please raise your hand. Okay, good. I'm assuming everybody here has heard of GE. Yeah? And how many people have heard of Siemens?
Yes!
Including the employees? How about Rockwell Automation?
Yes! All right!
See, you did better than you thought.
I don't have a fan club, but
And this might be sad, but in my former employer, ABB. Okay, better than I thought. That's fantastic. We're really talking about a world that I think is extraordinarily interesting in terms of the scope of the problem, the amount of data that's created, the kind of mission-critical nature of the applications that we're talking about. And I'm really happy to see such a good audience here today to talk about that. To really get started, I thought maybe we could have our panelists from Rockwell and Siemens talk a little bit about the kinds of end-use applications and things they see these technologies really playing into, and just really kind of set the context for when we talk about the industrial internet and when we talk about industrial automation, what that means and what that really looks like when it comes to delivering value and what gets created in terms of quantities of data and information to work with. Mitch, you want to start?
Well, sure. I'd be happy if you wanted to, but no, I'll take it. Well, if you look at the types of industries, I mean, you look at these applications, they're really spread across a wide range of industries, and typically you would say that these applications are, I would say the largest industry is barely over 2 digits, or I'm sorry, double digits, so a little over 12% or so, and that would be like food and beverage. Is where these applications are used, but it's spread across, I mean, just a wide range of industries. So like food and beverage, there again, you can start thinking of things like packaging, machines, You can look at bottling.
So we talk about packaging machines for a minute. Let's just build off of that. Because if you think about it, it sounds trivial and it sounds kind of basic. But if you were to get into the level of precision of control and the speed at which these things work, give us a sense for what that's like.
Any thoughts there? Do you want to
Well,
chime in?
I would probably just more go broad and say, we're talking about real-time control where the applications need to be up 24/7, 360 days a week. Downtime is critical. So, you mentioned food and beverage, but really everything that we consume, eat, drink, where, what's in our household, our appliances, what we drive, whether it be cars, trains, rail, along with heavy industries like oil and gas, mining mineral cement, and water, wastewater. Yep, people have to do that. All this stuff is automated. There's elements of it, whether it be through power or control automation. There's information elements to it. So to your point of getting a little more granular, when we talk about data, an oil rig in one day can produce over 1 trillion pieces of data in one day. It's massive in terms of what's being used at a real-time level. And I think one of the challenges when we start looking at big data is that, or what's the new buzzword, is that in these industries, this equipment is producing tons of data. And the biggest question that the folks in the market tend to have is, how do I use it? It's usually used for control and operator information at a real-time level. But they're like, hey, I've got all this. What can I do with it? How can I innovate with it? So, at a high level, there's elements of huge data. Downtime's also a huge factor here. So, one example of downtime in some of these industries, 1 minute of downtime could be $100,000. An hour could be multiple millions of dollars. It's significant, and it's critical in order for people to actually be able to, you can't stop production to try a new application. So anything that we're talking about here is how do we get things to be utilized? So a little bit less on the packaging line, but does that get a little more
so.
Yeah,
tangible?
but also, I think just sort of expanding in terms of how are these things, what are they doing in it? Like if you look at automotive and aerospace, well, we're actually, forming the metal, we're milling it, we're bending it and pressing it. Then we're taking it and we've got, you see a lot of robotics used there. So you've probably seen these on television, welding and painting, and those have been done for decades. Been using robotics there in those applications. So it's not even new there. And so you see these, and then of course there's, you start looking at oil and gas pipelines. I mean, these things are very long and very critical. We were talking to someone earlier who was working on analytics for compressors. And compressors are basically what you've got is a big jet engine. And what it does is it's compressing the gas, down this line. And so you can start thinking about, and these lines, like one of them that I'm familiar with called the Trans-Canada Pipeline, runs from one end of North America to the other. And they've got all these gas line fields, and they pump gas in other places and pull it out another, and it's just compressed. And it's actually, I don't know if you know this, but it's stored in the pipeline. So, you make that thing leak, and think about it. Bad things happen.
Summarize it as bad.
So again, and we're talking, if you start thinking of these links, we're talking about at least 3 tiers, meaning that you've got compressor stations, you've got valves and pumps routing stuff out to cities and consumers, and then you've got, so you've got these local area control systems that are picking data up, they take them into central control systems, and then you take those and you bring them into one massive local control center. Now, I don't really have the numbers on oil and gas, but you do the same thing with light rail, by the way. So in your local light rail, a very similar system, same software probably, that's running that rail pipeline. So it's whether you're transporting people or gas, about the same.
I think part of the message with all this is the scale and the size that we're talking about, which is, I think, makes this class of problems particularly interesting. Maybe, Rohit, you could talk a little bit about some of the work going on at Microsoft.
Yeah.
And the areas you find most interesting related to the topic.
Just fleshing out what Beth and Mitch were talking about, what is fundamentally different now, right, than what's been going on for the last 20 years? These have been built about 50 years or even 100 years if you go back, to the steam engine. So, in Germany they call it the fourth industrial revolution, and this is the convergence of connectivity that's happening with every device, and the convergence of, networking, low-cost sensors on these devices, bandwidth, the ability to store data cheaply and then process it in, vast volume. All that is converging together with exactly the framing that we just had here. So if you've got a compressor, any downtime on that compressor is going to cause a massive problem, in terms of what could happen. These are mission-critical, safe systems. If you have contamination in water treatment or water purification plants, that's a big problem, right? And there's a very high cost associated today with being able to manage all of these remotely. They're often very distributed assets, as these pipelines are, or water distribution systems are, et cetera. So the fact that you connect them just provides just a whole new level of value, which goes to safety, which goes to resource efficiency, which goes to energy management. So the whole economic value proposition that's created by looking at that data, by remotely managing these assets, and then looking at the efficiency and other safety areas of these, right? So we see sort of the transformation is really that companies that were building this in the past, they kind of, it was a transactional sale to their customer. It was, here's the hammer, good luck with that nail, right? And we're shifting now to, a continuous relationship between the manufacturer and the end user of that equipment, the customer. So it's a whole new business model. You could think of, the world sort of today is at the CRM boundary where you actually sell something, and now we're going into an ongoing life cycle. Somebody is smart in the analyst community is going to come out with some term like product relationship management. But
You expect credit for that as it comes out? But I think you're building on a point that sometimes gets missed, is the fact that so much of the technology we see, here in Silicon Valley, the level of connectivity, and we almost take that for granted. Of course it's connected. Of course I can reach it. Of course if there's an issue with my new Tesla, they can just push out an update and raise my car up by an inch and it fixes all of the problems. I mean, that's taken for granted. But in a lot of the businesses that we're talking about, that hasn't been the case. And we're bringing that connectivity out, in some cases for the first time, and in some cases we're bringing a level of connectivity that hasn't been seen before. And maybe you could talk a little bit about
Yeah, sure.
how you see that.
So I think that, if we kind of listen to the problems and also the opportunity we're describing, it kind of starts with you have to connect things together. That's kind of the foundation. So where Cisco has been focusing a lot of, in the past couple of years, is how to connect things no matter what kind of environment it is. Whether it's underwater, in the environment you mentioned, whether it's in a factory floor that would have a lot of electromagnetic fields, whether it's out somewhere in Africa or, the Arctic, which is very cold and hot, we try to at least get the things to be connected. Then that's when the data get connected and a lot of data get generated, and we are now exposing the data get generated. Now the interesting use case can be enabled, like now we can start figuring out, hey, now I have visibility to all these data, maybe, I can figure out where are the weak link in the oil pipe and proactively fix it before it actually go bad. So that is something that, we've been doing for the past couple of years. But one thing we did learn is, and I think Foghorn kind of spell it out, is that a lot of these environments, you don't necessarily have connectivity to the cloud all the time. So for example, the oil rig is a good example. It's just a lonely piece of big iron sitting in the middle of nowhere. If you try to ship all these data through a satellite link back to the data center on shore, that's going to cost you billions of dollars. So then the distributed computing or Fort node will come into play, because you want to replicate as much what you're doing in the data center to the in the oil rig platform, but you only want to sync it once for a while. So I think that now we are seeing is that with the explosive data, distributed computing, how to sync it up with the cloud becomes also very important. But with all that, a lot of interesting cases can get enabled, and that's where all the proactive maintenance comes in, and that's where I see the huge value comes in.
Interesting. I mean, when I think about this whole space, I mean, we look at the kind of innovation clock speed that's happened in most of the Valley, and not just the Valley, but worldwide. All of these new businesses, all of these new kind of infrastructure and architectures. I mean, there's just been so much kind of revolution that's happened in the last even 5 to 10 years that has been just breathtaking to watch. And if you look at some of these more established sort of industrial-oriented companies, there's a common criticism which says, oh, they move so slowly and it doesn't seem like much has happened and I don't know, not so interesting. I mean, can you talk a little bit about why you think that might be a perspective that some have and give your thoughts on whether or not you think that's an accurate portrayal, and if not, why not?
Sure. I mean, there's actually some statistics out right now that say that manufacturing is going to change more in the next 5 years than it has in the past 20. And a lot of that is because of the technology enhancements that are happening right now. There is opportunity for folks to try new technologies and test where the most value is going to be. And what I mean by that is you can't stop production in some of these critical processes to go to a new application or go from everything's on industrial controls to the cloud. We're just going to send all the data up, like we talked about in that earlier presentation. We need to keep the business running. We need to keep it safe and secure, and those are critical things for folks. So we talked about downtime and production efficiency and the economics. I can't stop making cookies. I got to be able to produce the revenue, and I need to be able to do it securely. Okay, security is becoming a bigger issue in this market. Before it used to be security by obscurity. Okay, nobody's going to touch my SCADA because they don't know how to go target it. They're going to target the corporate IT. Well, guess what? There's been issues, especially in the oil and gas industry, that really disrupted the whole environment, saying, oh my gosh, people know how to do this. So, I talk about safe, secure, et cetera, and they're having to make changes to their architectures because of some of these things. And yet, they can't go do rip and replace. And they're not going to. A lot of this technology is in the market, has been in it for 20 years. We're going to be dealing with legacy architectures here. But how do we start? How do we look at what are the right opportunities for using fog technology? What are the applications that make sense there? What are the applications that make sense to utilize the cloud? It's that scalable computing that's critical in these markets. There's going to be things that I would say that my lifetime will stay managed by an industrial controller. But I think we're going to start testing a lot more things that can be utilizing some of these IoT technologies. And we're seeing it today with our customers. One of the conversations we said is, hey, are they laggards? Are they using the cloud? Are they using mobility? Well, yeah, the answer is yes. The key is in what applications and where can they get the value in those applications. But once we start, we'll see it grow, but we have to prove it out.
Yeah, I agree. I mean, basically, it's two things. I mean, risk of doing it, and then in some cases, risk of not doing this. And again, with a disruptive technology, I was in the industry when the PC actually entered it. And I remember going to industrial automation shows and seeing a PC, one or two, in a couple of booths by a few customers kind of playing with it in 1984. This is 2 years after the PC's out, late 81. And so very relevant, that's sort of a relatively early adoption of a massive, but by 86, if you did not have a PC-based solution, you were considered sort of not really in the market. And it was the whole market shifted. So, and that was pretty radical because we were talking, again, a lot of Unix and VAX, and you may remember some of these names, computing technologies that were considered really hardened and more reliable, but yet we went to PCs running not Windows, but DOS, and basically controlled the world with that, basically for almost a decade. And so that was a very rapid, and those that did not go that way really lost out in the market. I mean, it was really changed the landscape. And so it was, in my mind, a very rapid, major adoption in the industry. Now, there wasn't a lot of rip and replace, but it was new and augmented systems. And so that's the other way to look at it. And so the easiest intro is when you're going to augment an existing capability and improve it in some way that's not disruptive or risky to them shutting down the process or losing production, I mean, or whatever, you know. So again, analytics really is, big data is a good place for that type of thing, because usually you're just out there perusing the data and providing information that they did not have before.
We talked about getting kind of access to the data in the volume and in closer to real time is certainly more of a shift that we've seen happening. There's been a lot of talk at the in the industrial world about this convergence of what IT and what the term OT. Everybody here familiar with the term OT? Yeah, put that maybe a third. So maybe could somebody kind of describe OT a little bit and what that means, and then maybe talk a little bit about this convergence that we see happening.
Sure, I can take a crack at that. So the plant, when you think of the plant and the factory, right, as an environment, and then you think of data centers that run the enterprise systems of a company, these tend to be two very distinct things in most companies today. So the stuff that's in the plant or the factory is typically under the control of the plant manager there. They're very protective about it. They got to be, because for all the reasons we just discussed, the safety, etc. And then you have the IT part, which is delivering the sort of the PC access and the applications that run on the back end, etc. Right? So these two have been traditionally governed very, very differently, and there's been very little convergence. And the internet actually is forcing now security to drive from the IT experience into the plant itself. And we're starting to see a little better integration. But essentially, this has been the world of operations technology. So all these things, when you talk about pipelines and water treatment centers and oil rigs, falls under the category of operations.
And the technologies below that, the PLCs and the control systems and all the other things, all the technology underneath that makes all those things work.
Yeah, if I were to spend 60 seconds on what the topology of that is, typically you'll find these hardware, you've got the physical infrastructure, the conveyors and the motors and all that, and above that you have the PLCs, which receive signals from these things and control all of that automation equipment. Then you have a layer above that, which is typically PC-based, looking at the PLCs, providing the HMIs, the operators, so they know what's going on. And that then connects up to the ERP and supply chain systems, which eventually take a more sort of global view. The semantics keep changing as you go from real time at the bottom up to more aggregate levels at the top. And that's sort of how the OT and IT in a sense tend to intersect. And that's why there have been so many, the problems that exist today are a legacy of this division. You've got silos. You've got your PLM system, which does design and manufacturing engineering. That's the world of R&D and engineering. Then you've got the supply chain and finance and HR, which is the world of enterprise software. You've got production, which is what we call MES, or manufacturing execution systems. These are the things that coordinate the flow of materials and equipment performance and all of that. And then you've got distribution and CRM systems, which are customer-facing things. So that's a very fragmented landscape. And what's happening now is the digitization aspect, where there's so much digitization at every level and in every system that companies are finally starting. We've talked about this for ages, actually. How does all this come together? At the end of the day, you're trying to make a product that customers love and want, right? But there's all these other sort of breaks in the process. And now with big data, essentially, we're getting to a point where it's like, look, you don't have to schematize everything up front and design the sort of monolithic one enterprise model that's going to connect everything together. But rather, we've got these capabilities to say, let's pick up wherever the data is in whatever form, structured, unstructured, and then use that compute power and storage power that's become cheap to reason over that and say, how do we connect the dots between how a piece of equipment may be performing in the field, and is this a manufacturing problem or is this a design problem? These remain rich white spaces today that companies are starting to address.
I was just going to say, how many people here would consider their current job in OT? Okay.
I think 5.
A few folks here. And I think that's important because I know from a Rockwell Automation perspective, we've actually been teaming with both Cisco as well as Microsoft over the last, probably longer, but 10 years for sure, to look at how do we help that convergence of IT and OT. And what does that mean, right? It's starting to put people in the room together. We did some thought leadership councils with Microsoft and customer innovation councils with Cisco, where we literally had Microsoft and Cisco bring in IT professionals, and we brought the manufacturing and operations folks. And in some companies, they didn't know each other and didn't want to engage. Okay, very division. And I think I started doing some of these in 2007. Now what's been interesting over the years, because we've been doing them on an annual basis, is there's starting to be a merge of persona. People who have gone from one side of the house to another to learn. And that's where you're starting to see collaboration. And yet, it can break in a minute. We just had a session about a month ago, and there was a fellow right there that said, it's not necessarily about technology, it's culture. And he said, right now my relationship with IT is going well. He's working with me, we're engaging, we're creating projects, but if in the next minute he doesn't respect what I do, I will no longer collaborate with that person. So even though we've made a lot of progress, right, it still comes down to culture. And that's one of the things we see as very important for us as a company in the industrial side, is to continue to innovate and collaborate with IT companies so that we can bring our knowledge and experience and domain expertise in the industrial side and be able to almost help translate using Microsoft and Cisco to help communicate to the IT side so we can come together and actually create solutions that work. And it's IT, it's the technology plus the domain expertise that's going to make it real.
You bring up a really important point, I think, which is you can look at this as a technology problem, and there's a series of technology trends that are driving this. But there's a series of other issues related to culture, related to just industry forces generally. Maybe you can talk a little bit about just how you see some of those. Is it really the technology that's driving this? Is it the reshaping of how some of these large companies and competitive pressures are almost forcing this to happen? What do you think is really driving it?
Just adding to the culture question, I mean, I read something the other day that sort of described the priorities of what it was that IT saw, and again, in manufacturing, and specifically, and IT is really was a primary, their number one issue was how to protect the intellectual property, right? And if you think of that, if you've ever worked in a large company, the IT folks are there to prevent you from doing things, right?